So for instance, if you have cosine of a plus b is equal to cosine a cosine b minus sine a sine b. Yeah, we got just enough time. So if I let b equal a, I let the second angle be exactly the same as the first angle. It's like cosine of 45 plus 45. I don't remember. Probably.
Like you can switch the things and it would still come out the same, right?
Oh, if they're exactly the same and switch them, that's fine. But
no.
We were just talking about plus, and plus is commutative anyway, so it doesn't matter what you're talking about. Does that make sense?
No, what I asked was if you have cosine a plus b and you do cosine b plus a, would cosine b cosine a minus sine b sine a, would that be the same thing?
Yeah.
So is that what basically this is doing?
This one is letting b be exactly the same as a.
Oh.
So when I rewrite it, it becomes cosine
2a.
of 2a, yeah, a plus a. And then that's going to become cosine a, but cosine a times cosine a is?
2 cosine a.
Cosine squared a, minus, and then this becomes sine a sine a.
Cosine squared.
Oh, come on.
No, sine squared a.
Sine squared a. So you get this identity.
Name of one.
It's called a double angle identity.
Wait,
No, that does not equal 1. That's cosine squared plus sine squared. The problem with this one is it's one of the identities. There are 2 more. Why? Because I can replace sine squared with
cosine squared minus 1.
close to a cigar.
1 minus cosine squared.
Alright, so then that becomes cosine squared a minus parentheses 1 minus cosine squared a.
Hold up, what?
Replace sine squared a with 1 minus cosine squared a.
And that would be 2, or the cosine squareds, they don't cancel. 2
No, 2.
cosine squared a minus 1.
2 minus 1. This is also considered the double angle formula for cosine.
Okay.
We could also take cosine squared a and replace it with
Sine minus sine squared minus 1.
1
1 minus sine squared.
I'm sorry, 1 minus sine
So you get 1 minus sine
squared.
squared
Or
a minus sine squared a. This becomes 1 minus sine squared a minus the sine squared a that's already there. So that becomes 1 minus.
1 minus 2 sine squared a.
Where did I lose you?
I'm
I'm replacing this with that.
1 minus 2 sine squared
Pythagorean
a.
identity. And then I'm just going to combine these two.
1 minus 2 sine squared a.
Yeah, 1 minus 2
sine squared a. And this is also cosine of 2a.
C.
Now that's just a cosine. It gets special treatment. It allows you to change a cosine into both sine and cosine, just cosine, or just sine.
Your board is very clear.
I don't know why. What if I had the sine formula, sine of a plus b? Sine of a, cosine of b, cosine of a, sine of b. Is that right?
Sure.
Okay. And I let b be the same as a. In other words, change b's into a. So if I do that, I'm going to come up with sine of 2a.
2b.
I'm changing b into a. You get sine of 2a, so this becomes sine of a, cosine of a, cosine of a, sine of a.
That means nothing.
Wait, repeat
All right,
that.
reverse the sign of the cosine here. Write it as this. You might see it a little bit better then. Sine of a, cosine of a, sine of a,
Oh.
cosine of a.
2 sine of a, cosine of a.
And this is the only double angle formula for sine.
Okay. So are you going to give us those?
Maybe.
Okay, I'll write it.
Maybe. These Call of Duty 2. Great.
Call of Duty? I've never played Call of Duty.
Continue.
Or Black Ops.
5-3.
We never started 5-3.
Yeah, we did.
No, we didn't. No, we didn't. No.
Yeah, we did.
Oh,
Wait, we didn't.
You never told us we did.
I know.
Democracy.
I didn't want you to whine and complain as I started it, so I just kind of ran into
Wait,
it.
so where does it begin?
Ooh. We did these yesterday.
But the double angle.
The Devil Wears Prada.
It's a good movie.
That's-
Yeah, it's a band. It's a band.
No, I know it is.
They sing screamo mess. It's not actually that great. It's not that great. That's the thing.
Always screaming in this class.
This is all we did yesterday, except for I think we did tangent too.
You just did tangent, didn't you?
No, tangent of 2x.
No, we didn't do that.
We didn't do tangent of 2x?
No,
We
we
started
didn't
signs.
do
Ah, let's do tangent of 2x. It's real easy.
Wait, where did we get that?
I'm still trying to figure
Yeah,
out what
can
we're
you
doing
explain this again?
Oh, where did I get this?
now. Yeah.
Where'd
That'd
you get all of it from?
be a great
Yesterday.
start.
I had it all on the board.
Oh, you
I
did?
was a little bit
You
All right.
used 2A, that's right.
This
Chelsea
one
was
here.
distracting me.
This one here was cosine of a plus b is equal to cosine a cosine b minus cosine a sine b, right?
Yeah.
Then I let a and b be exactly the same, so we got cosine of 2a is equal to cosine squared a and sine squared a. And then I manipulated the cosine squared and sine squared into some various forms. 1 minus sine squared and 1 minus cosine squared. So these three first ones are the cosine of the double angle. Cosine of 2 times the angle. Sine only had 1 because the sine formula is sine of the first, sine of the first, cosine of the second, plus cosine of the first, sine of the second. You have to reverse their order to realize that when you make a and b the exact same, you get just 2 of them. Yeah? Which one? This one? This one. To get this one, you take sine squared over here and replace it with 1 minus cosine squared. And then to get this one, you replace the first one with 1 minus sine squared. Out of the two of them, these two are the most important.
I think you already proved these.
Yep. That was yesterday.
Question. So are those two
You weren't
exactly
here
equal?
yesterday, I was here.
These are all equal to each other.
He always
All
proves
three of
it.
them.
He writes down.
Okay.
Wait, say that again?
All three of these are equal to each other. Obviously, they're all equal to cosine of 2x, so therefore they're all equal to each other. Transitive property or something silly like that. All right, how would I prove tangent of 2x?
You just give us the formula.
Nope.
You would get a purple pen out and.
You get the sine over cosine thing?
No, you could do it that way, but you could also use the identity. I really shouldn't have written that. Tangent of a plus b. What's the identity for tangent of a plus b?
Oh, give me a second.
It's tangent A.
Tangent a
Tangent A
plus tangent b
over
1 minus tan a tan b.
This is where you get the 1 and plus. That's what you did a minute ago. That's what you did.
Yeah, this is the identity we used a little while ago. And then yesterday, this is all we were doing. Let a equal b, or vice versa, b equal a. Doesn't matter which one you do. So if I take the b's and replace them with a's, I get tangent of 2a is equal to.
You said let A equal B, so
Yeah,
you're
a
right.
equal b, b equal a. It
2
doesn't
tan
matter.
A.
So it becomes a plus a, which becomes 2a. This is tan a plus tan a,
2 tan A.
2 tan a,
2 tan A.
Pretty.
over 1 minus,
2 tan A.
no, it would be tan a times tan
Oh,
a.
tan squared A.
Tan squared a. So this becomes this identity. So you get 2 tan x over 1 minus tan squared x.
It'd be a light step.
What's that have to do with anything?
I don't know, I'm just thinking of like medicine for the future.
So all of those were just you giving them out on the test.
I will give all of these to you on the test.
Thank you.
These are semi-confusing. On the final, I actually give you every single identity, including the sum and difference ones.
For the 2 tan A part right there.
Is it
up,
right?
can you turn that into 2 cosine A over just cosine A?
Why would you want to?
I don't know.
You could do any manipulation you
That would
want.
be cool.
Now I gotta put it in my notes.
Maybe,
Done that. Done that.
we should do a still count.
Verify.
We just don't.
These aren't too bad. Sine squared y is equal to 1/2 1 minus cosine of 2y.
What in the world? Is this an example or you're doing
this is an example, verifying an identity. So I have to prove either the left side turns into the right-hand side, or prove that the right-hand side turns into the left-hand side.
Can you let us try?
Looking at your crotch. The only thing we can replace on the right-hand side is that.
And it's gonna be cosine squared minus sine squared.
We could, but if we use this one, we're going to be stuck with a cosine. The other side is just in terms of sine. So out of these three,
Two sides.
That one.
you want to use this one because it's the only one that has plain old sine.
Sine squared.
So this becomes 1/2, 1 minus, parentheses,
1.
1
Minus
2 sine squared
Y.
y. I don't know.
Why not?
Oh, I knew that was coming.
Ooh,
That's just so predictable.
I would
You do
really have
believe-
to
This
use
becomes
the
1/2.
because the times one,
What's that?
right? Just as in,
Is that a 2y or?
Oh,
I just
Here?
think there that
No,
look
it's
Here.
cosine. Here.
this one?
Yeah.
Yeah.
2
I didn't know if it was like
You go
cosine
to
squared.
Is it just two sine squared y?
Well, hold on. 1 minus 1,
It cancels out.
negative times a negative.
Positive.
So this becomes 2
Yes, I'm right.
sine squared y.
Why are you so jumpy today?
Who?
Nick.
Nick?
I was checking the back
I
lines.
see you
Yeah.
one.
nice.
Half of 2. 1 sine squared.
Oh, that's boring.
That wasn't that bad.
Surprised you can say that. Oh, this is boring.
Nick? Sine of 2 theta. Oh, no. Don't want to start there. Give it.
It's a good song. I'll shout it.
Mary.
What? She's talking to me.
Shut up.
Oy.
Audio feels.
Alright, so what do I know? Well, if I give you this and this, what do you do first?
Make a triangle.
Make a triangle, draw a picture, get it in the right quadrant. So what quadrant are we in?
Number 2.
First, second, which one?
Third.
Second.
Second. Why? Because it's pi over 2 to pi. So your angle is over here. This is your theta picture.
Oh, we did this.
Kind of, yeah. It's similar for the sum and difference one. This is just double and half.
Oh, we did the sum and difference. Oh, okay.
We did that yesterday, yeah. So sine of theta is equal to 3/5. So this side is 3, this side is 5, and the last side is 4. But make it negative. That way you don't have to worry about all students take calculus.
I don't.
All right, so sine of 2 theta equals what?
I don't take calculus yet.
2 times sine of theta. What? Sine of 2 theta is equal to 2 sine theta
Cosine theta.
cosine theta.
That's all we had to do.
Well, now you just have to substitute in things
Oh.
because we're trying to evaluate this. Biggest mistake I've ever
Is
seen.
that an identity? The green? I mean, you put-
The sine of 2 theta equals 2 sine cosine? Yes.
That's an identity.
That's a double angle. It was written right here.
Oh, okay.
Gotcha.
Yeah, there are the 3 cosines, the 1 sine, and the 1 tangent. All right, sine of theta is equal to 3/5. The mistake I've seen here before is people write sine of 3/5, which makes absolutely no sense. Just substitute in 3/5 for the whole thing. Cosine of theta,
Negative 4/5.
-4/5. And we get
Excuse me, Mayor.
24 25ths, negative, something like that.
Oh, no, I wish I had my camera.
You wish you had your calculator.
Yeah, I got.
Oh, you don't have
Hold up,
it.
Yuri, I'm not using mine.
for?
Probably you're getting a girl, dude.
I'm
So,
not using mine.
sine of double this angle is going to equal negative 24 25ths.
That's easier than.
Yeah.
Identities? Oh, yeah.
Yeah.
Yeah, definitely. Most people screw up identities and do that perfectly fine. What if I wanted... What was the other one?
It's like, why is the bottom one doubled again? Never mind.
I had double
Theory.
that.
Never mind.
I had double that.
Never mind.
What's cosine of 2 theta? Now, the problem with cosine of double angle, you get a choice. And it really doesn't matter which one you use here, you'll get the exact same answer. So which one seems the easiest? Out of those three that we had.
2 cosine squared theta like 1.
That's my favorite. So 2 cosine squared theta minus 1. Now be really careful with this. It's 2 times something that's going to be squared minus 1. Don't forget that it's the answer that's being squared, not the angle. People do weird things with that squared. So this is actually cosine of theta, and in this case, what's cosine of theta equal to? Negative 4/5. It goes in here. Negative 4/5 squared
16 over 25.
times 2
32 over 25.
minus 1.
Hey, I can't do that.
7/25. 7/25, sir.
Wait, it's
So-
negative 7.
Mr. Calculator got it. 7/25, sir.
I invented that, you know.
Or you type it in your calculator.
Is it negative?
Work smarter, not
Is it
harder.
I
negative?
said never mind. Yeah.
Heard that?
You know, negative squared goes away.
Work
So
smarter.
you get
not
cosine
harder.
of this double angle equal to 7/25. Yeah, those aren't too bad.
One's a little harder now.
These are the hard ones. Continue.
You'd rather here's the question.
Power reduction.
Don't need it,
This is definitely one of my favorite test questions.
Of course it is.
It's horrible.
Of course it is.
For the power reduction formulas, we're going to use this formula. He's an alien.
Bless you. Our teacher today told us why aliens have not invaded Earth.
And why is that?
Mr. Acker said that we have so many diseases these days that aliens cannot.
But aliens can bring their own disease and kill us all.
Well, I think you're an alien, so.
You're all gonna die.
You got another.
Okay. Using this identity.
Half alien.
Using this identity, solve for cosine squared. What would you do? If you're going to solve for cosine squared of x,
Oh, for what?
if we're going to solve this equation, get cosine squared by itself, what would be your first step? Take the 1 over.
Yeah,
So you get cosine of 2x. I'm going to put the 1 in front of it. And then eventually you would
divide by 2.
divide by 2. So this is a replacement for cosine squared of x, rather than 1 minus sine squared of x.
Okay.
Alright. What's nice about this replacement is you're going from a power of 2 to a power of 1. You've taken the power on the cosine and reduced it.
Well,
So this is called a power reducing
You said-
identity.
you said we've gone from what?
A power of 2 on the cosine to a power of 1 on the cosine. There's a 1 here.
Question.
Yeah.
Okay, so what if it was cosine cubed 2x?
We'll get to that later. Be patient.
You always ask.
I know. She always leads me into where I don't want to go. There is also this identity.
Cheese and rice.
For the cosine double angle. Under the same logic, if we solve this, oops, I forgot something. 2. If we solve this for sine squared of x, what would you do?
You same thing, right?
1 plus.
Well, similar, but some of the order.
No. It would be negative 1.
Well, honestly, I would take this piece here,
Turn that into cosine.
bring it over to the other side.
Why?
So it would be 1 minus.
Because instead of having it being negative 2,
It'd be positive.
Wait, hold on. What? You would take.
I would take this piece that's negative, drag it to the other side, it makes it
So it would be 1.
positive. Take this piece and drag it over here and make it negative. So it becomes 2 sine
Or it becomes 1
squared x equals 1 minus cosine of 2x.
And then sine squared x equals 1 minus cosine 2x over
2.
Over 2.
Right. So the formulas are very similar. It's just the sine version has a minus, the cosine version has a plus. So these are the power reduction formulas. This is sine
And
squared.
you're going to give us these, right?
Sure, why not?
Good.
Because the harder part is using them.
Oh, good.
Yeah.
Oh, great. Now Sammy said, what if it
I shun you.
cosine to the 4th x?
I was going to ask that.
Nah, yeah. This one's actually easier than that one.
It is.
In a weird way.
Because it's going to be
That sounds
cosine squared x.
Cosine squared x times.
How about we wait 1 second after the
We extend our language words. There
That's
is
what Chris Jacob does.
what?
Is what
Sings
we're
it out.
He talks fast and he talks real slow.
Yeah.
End of the sentence.
So I can replace cosine squared with
Cosine 2x.
1 plus
Cosine 2x.
cosine 2x over 2. And I can do it again over here. 1 plus cosine
Just make it square.
2. No, you want to see both of them. Over 2. You square it and then all.
It gets messy.
Plus, what can I do with these two 2's?
4.
It becomes a 4, so I can yank it out as
A janky.
1/4.
1/4. So this becomes 1/4. 1 plus cosine of 2x times 1 plus cosine of 2x.
How high are these gonna
You can have them go as high as you want.
go? How high are you gonna have them go?
4.
Alright.
4 is high enough because you'll see what happens in a second.
Did you do 1/4 because of that?
When you multiply the denominators together, you get a 4 in the bottom.
Oh,
So when you
okay.
yank it out, it becomes a 4th. So the best thing to do is get rid of the fractions in these two terms. Otherwise, it's
We just
horrible.
like keep a fraction, put 4 at the top, then put a line, and then just 4 like at the top.
I guess you could, but I'd rather you get rid of the 4th right away. Alright, FOIL the things on the inside. 1 times 1? 1. 1 cosine 2x and another 1 cosine 2x gives you 2 cosine of 2x. And then the fun one. Cosine 2x times cosine 2x is
Cosine squared 2x.
cosine squared of 2x. The problem is, we still have a square.
I don't see no problem. I like it.
You like it? Well, you need to get rid of it. So, the first two terms are perfectly fine. What can I replace cosine squared of 2x with?
1 plus cosine 2x over 2.
No.
Whoa.
Really?
Oh, wait.
Wait,
It's a
wait,
square
can we just
2x.
can we pause for just a second?
Pause.
1 plus cosine of 4x.
Yeah, when you do the substitution on this thing, you have to take the angle and double it.
So if it was like, say it was like cosine squared of like, if we ever got like 6x, so it would be like 12x.
If it was 6x, you would have to double it to 12x, yeah.
Alright,
If it was a half of x, then when you double it, it would just become single x.
well, the way I had it, like with the fraction, couldn't you just divide by 2 and you get a 2 at the bottom and then just divide the 2 by 2 and now just get rid of the 2? And then just
Okay,
So many
I'm
twos.
really confused about what you just said. You're almost as bad as my daughter over here. Let me write it and then let you say it. Ready? This becomes 1 plus cosine of 4x over 2. Now, are you saying take this 2 and divide that 4 by it?
But no, you can't do that.
I know you can't do that. That's what I'm worried about.
Yeah, I got the 4, but I
I mean, I'm just saying like the 2, okay, there's the 1 plus 2 cosine.
Here?
Okay, that one.
What about it?
I mean, if you were to have the 4 underneath that, then that 2 would just.
Become a half.
Divide everything by 2.
I mean, when you distribute it, it'll become a half.
Divide everything by 2.
That's why I like the 4 way out front, so you don't have to worry about him. Now, this one causes its own little headache.
Hold up. How do you get the 4x and why do you put it over a 2? I don't.
I
Alright.
got the 4x.
The identity is this. Cosine squared x equals 1 plus cosine 2x over 2.
Right.
So, if I say, well, let x equal 2u. Right? Well, if you do that, then it becomes cosine squared 2u is equal to 1 plus cosine of 2 times 2u
Alright.
For you.
over 2.
Yeah.
Better known as 4. So it just doubles the angle when you pass it over the equal sign.
Writing this down, scooping this up.
So if you had
No.
cosine squared of 4x.
It always doubles. And it's always over 2, yeah. Okay,
Always.
Multiply everything by 2. Can you do that?
so this becomes a half.
Yes.
A half plus 1 is?
A whole.
It is not.
3 halves.
3 halves.
It's 3 halves.
So you get 1/4. 3 halves plus 2 cosine of 2x plus
Oh my god.
1 half of cosine of 4x.
Are you done now?
Nope, we still have to simplify it a little bit.
I don't want to simplify it.
I hate this.
So why did you divide everything by?
I only divided these 2 by 2.
What about the?
But
If
there's
you
nothing,
take out a
there's
half.
nothing here
If you
anymore.
take out a half.
I can't take out a half unless I say, distribute the 1/4 back through and you get 3/8 plus 1 half cosine of 2x plus
1/8.
1/8 cosine of 4x.
That's not simplify.
That's as simple as you're gonna get it.
But I thought with simplifying you would take out.
That is compound.
That's as simple. All we've done here is we didn't simplify it. Look, it started with
Never mind,
cosine.
never mind, never mind, never mind. You're not getting
How
out.
did you get 3 halves right there?
This one? You got a half over here. This is what happens when you're not listening. You get a half over here, and you get a 1 over there. If you add those together, it becomes 3 halves. I said that.
Well, why do you have to add them together? If
Because
it's
they're like
They're like terms. If you have x minus 2 times x plus 3, what do you get out of it? X squared minus 2x plus 3x minus 6. Do you just leave them sitting there?
Yes.
No.
No, you add them together because they're like terms.
Horrible.
But okay, because the 1/2
It's 1/2.
is multi.
1 plus cosine of 4x divided by 2 is the same thing as 1/2 plus 1/2 cosine of 4x.
Oh, I said that.
Yeah, but I don't understand your logic.
I said that exactly. I said 1/2 plus.
It looks better on the board.
It looks better on the board.
Shut
She's a
up.
visual person. She can't understand
Okay,
it
I
when she hears
understand
it.
now.
Okay.
See, I got 1.
Pulling teeth.
Glad you did.
Sine squared x cosine squared x.
So,
This one's easier. Try it on your own.
okay.
This one technically is much easier. It's that loud whisper. What?
Let me see. I'm pretty
Oh,
close.
is that right?
Alright.
You have to start at them.
Oh, it's supposed to be.
No. As far as I get. 1 minus cosine squared. That's probably why things aren't working out.
Is it?
Miss AI.
Just let me come on, is this it?
Wonsky.
Can you show me the number?
See, I was someone right.
Can you not read it?
Am I close?
But now you have to, that's a square, right? You
Yes.
can't have a power.
I give up.
There, I wrote it nicer.
That's what you did.
But it's right, right?
It'll work.
It's
It'll
right.
work. It'll work.
It's right.
I think
There.
so. Yeah, you have to just change it.
Here, can you read this now? Can you read that?
Can I read your handwriting? Okay. It's not close.
I didn't do all the work. Because I changed my writing.
Yeah, but see this minus sign?
Yeah.
It distributes.
Uh-huh.
So that should
Oh.
be minus.
Okay. So I just made one simple mistake.
Well, I think there's actually 2 in there. It should turn out easier because these things are conjugates. When you multiply them together, you get the square of the first term, square of the second term. So, pull out a fourth. Left behind with 1 minus cosine squared
Thank you.
2x.
See, I already had squared.
Right?
Can you?
So then this becomes 1/4,
Oh,
1 minus,
I know I went wrong.
1 plus cosine of
4x
4x
divided by 2.
over 2.
Take out a 1.
Then my suggestion would be just
Distribute it.
distribute and be careful with this too. So this is 1/4 times 1 is a quarter. A quarter times a negative times a half.
Oh, shoot.
As I said, you have to be really careful with this
Negative
one.
A.
This is a quarter times a negative times a half, which is negative 1/8. And then a quarter times a negative times a positive. Negative 1/8
Hold up.
cosine of 4x.
Oh, I know what I did. That should be one.
Okay, so that's
Now, if you can't follow that along, my suggestion to you is distribute this negative first, pull out a half. Actually, pull out a half first and then distribute it. So to make it a little easier on the eyes, so you can see where all the pieces are coming from, I do that. And don't do as much in your head as you want to. So this becomes this, and then this becomes this. Right? Combine these two, it becomes
One
a
minus.
half. A half times a quarter is an eighth. Then this is negative 1/8 cosine of 4x.
Can you make that into 1 minus cosine 4x over 8?
Yes.
Make sure. That's what I had.
Yeah. So that's power reduction.
What the heck is that evil plan? God, look like you're gonna kill me.
So the answer is
This. It's actually easier than the answer for the other ones. So anything with a fourth power, or if you have square times square and they're two different functions, that's the fourth power one is always messy. So take a guess. My fourth power one on the test is sine. Sine to the fourth.
I'm gonna buy a little more.
Bible.
Why? Why are you
It's very religious.
just
Can you prove it? Show me the money.
show me the money.
Show me the money.
JJ.
Half angle formulas. Back to these. Cosine squared. Oh, no. Hold on.
Anyway.
Cosine of 2x, there is no review day, is equal to 2 cosine squared x minus 1.
Why?
Why not?
No, really, why?
There's too many letters
Why not? Where?
in the whole thing. Just give up, man. It's not math class anymore.
Oh my god, it's English. You should see some of my other classes.
My head's about to explode.
What's the one that has physics in it?
A little bit.
That you were teaching?
Calculus and differential equations.
That one.
I'm just a farmer.
I'm just a farmer.
I'm not feeling it.
Alright, so here's how we're going to get to a half angle. Let
Be a beach
x
ball.
equal u over 2. Let x equal u over 2.
Oh, that's a U?
That's my u.
I thought that was a 4.
Yeah, that's my u.
You
If we do the substitution, 2x is going to equal directly plain old u. So far, so good?
yeah, all you do is just
Why am I doing this? We'll find out. Substitute it back into this equation up here. It becomes cosine of
U.
u is equal to 2 cosine squared
U, 2.
of u over 2
U, 2, I like it.
minus 1.
Let's expand. U, 2.
Now, the goal here is to come up with a half angle formula, so I need to get this piece by itself. So it's kind of like a power reduction, except we're going to go a little bit further. I want to get cosine of u over 2 by itself, no square. So the first thing you're going to move, of course, is
1.
the 1. Then you're going to divide by 2. And then eventually, to get rid of that square, you're going to
Square root it.
square root it.
Oh, I was right.
So you're going to get this ugly thing. 1 plus cosine of u
oh my god, literally.
over 2.
Why can't anything you please?
Now,
That's
that's ugly. I'll give you that. This one is
donkey.
it's probably one of the uglier ones.
It's a catch.
Now there's a problem.
I'll take a picture of it.
There's a plus or minus here because we square rooted both sides.
Yeah. Why is that a problem?
Wait, why
Well-
did you square?
There's 2 different answers.
It was add 1, divide by 2. It was just like the half angle or the power reduction.
Have you told us what the formula is yet?
That is it.
That's the formula?
That's the formula.
Okay, I'm
Let's take a
sorry.
picture of it. I'll point to it. There you go. Now it does have a plus or minus, but here's the cool thing. If u is any angle between 0 and 360, half of that angle is between 180 and 0. 180 and 0. And cosine from 0 to 180 is always
Positive.
positive, so we don't need the plus or minus, we can just leave it as
Yay.
positive. So this is called the half angle formula for cosine. This one is actually kind of useful for coming up with different types of cosine of angles. You could start off with like 30 here. Half of 30 is 15. We already came up with a cosine of 15 degrees. It's like square root of 6 plus square root of 4 over 2. So it would have a similar angle. Then you could take that one and cut it in half, and half of 15 is 7.5. So then you could find the cosine of 7.5. Then you could take half of that again and find the cosine of 3.25, whatever it is. And you could keep doing that for ever.
What, and then?
Why would you want to? I wouldn't. Neither would I, but you could if you wanted to find out different angles. The sine one is very similar. What's the only difference between the sine formula and the cosine formula of this?
Negative.
It becomes negative, so you get the square root of 1 minus cosine of u over 2. It loses the plus or minus. There's another reasoning behind it, but I always forget what it is. And when in doubt, you could always, like, if you know what your angle is going to be over here, then you can determine if it's going to be plus or minus. Like, the angle ended up in the second quadrant, guaranteed negative.
So is this one plus or minus?
This one is determined on your own.
Meaning?
You have to know the location of u over 2.
What?
You have to determine if it's plus or minus based on whatever u over 2 is. So if u over 2 turned out to be 91 degrees, it's negative.
Why?
Because sine in the second quadrant is
Positive.
Negative.
all students. Darn it. Then, this is the one you determine, the cosine one. You determine whether it's positive or negative. The sine one, it'll give you the right side.
Beat him at a dog game.
Darn it. I had it backwards.
So you said what?
I'm gonna sleep.
Cosine, you have to determine what the location of u over 2 is before you can say positive or negative. But I'm quite sure, if my memory serves me, you just leave it alone. And this one, you leave it alone in one way or the other.
Okay, which one do you
All
use first?
students.
Wait,
Because
so you're
if you take an angle between 0 and 360 and cut it in half, you're an angle between 0 and 180. Sine's positive for all of those angles. So this one is always going to be positive. This one you might have to determine whether it's positive or negative. But usually you don't have to worry about it.
Now, here's a question.
You can ask.
You can ask first.
I'll let the young lady go.
Oh
So
my
if it's
God.
positive.
Determine.
No.
Hold on.
No,
Determine.
listen to my question. Let me finish my question.
Based on u over 2 and quadrant. There. Okay, now ask your question.
Okay, so no, oh,
Perfect. She wasn't done yet.
okay. So I'm still confused. Like I know that you said determined based on
Location.
u over 2.
Right.
But if sine is gonna be positive,
For
then you
any
just-
angle, as long as it's between 0 and 360. If I go beyond that, then all bets are off.
What?
Ah, if you're at 0 to 360, you cut that in half, it's 0 to 180.
Yeah.
In the first two quadrants, sine is positive. So if you keep your angle 0 to 360, this formula doesn't need a plus or minus, it just needs plus. If you go beyond that, though, all bets are off. You have to determine where it is.
Oh, because it's a square root.
Well, the square root's going to be positive one way or the other. But when you square root both sides of an equation to get rid of the square, technically you tag on plus or minus.
And that's depending on where it is.
Depending on where the angle is and what function you're dealing with.
Determines what it is after you're done with the square root.
Right. And whether it's going to be positive or whether it's going to be negative.
Okay. That's all you had to say.
I thought I did.
No.
In what planet did you decide that you wanted to torture people with that?
What planet? This one. Oh, you're thinking of an alien.
No, seriously, what would you
Uranus.
want to become a math teacher?
It's not that I wanted to torture
Uranus.
I think it is.
Though I probably would have been great at the Spanish Inquisition.
Spanish Inquisition.
Look it up.
She
Pay attention in history.
Good history.
Did we even learn that?
Yeah.
You should have.
But it has nothing to do with U.S. history. It's Spanish.
Oh, that's true. That's history, period.
But we're in U.S.
Oh,
history.
that's the only
As in
history
us,
that
as in
matters.
America.
World history.
I'm not yellow.
We're in the only
Oh.
history that matters. What
I
about
thought you were saying I was Asian.
tangent half angle. We don't have much time. Hold on. Tangent half
Not
angle.
all Asians are smart people. We'd be amazed.
If you don't know what tangent is equal to, you change it into what?
Sine over cosine.
Sine over cosine. So this becomes sine of the half angle
So is it?
over cosine of a
So
half
is it
angle.
those two stupid formulas over each other?
Yep.
Oh my God, kill me.
No, it's not that
I
bad.
don't want to.
This becomes the square root of 1 minus cosine u over 2 over the square root of 1 plus cosine u over 2. Those two ugly formulas. Oh, by the way,
Common denominator?
no, just plus or minus on both of them, technically. So I'll just tag it in there.
But then in the end it would become, well no, it wouldn't. Never mind.
What goes away?
The square root.
Negative.
No.
The positive.
No,
The two.
the
square.
2's.
Yes.
The 2's definitely cancel. So this becomes a big square root of 1 minus cosine of u over 1 plus cosine of u.
Kill me.
That's one of the formulas. Is it the nicest one?
Nah.
Heck no, look at it, it's horrible. And this also is plus or minus, though what's funny about that one is you can actually drop it. But that comes later.
God bless you.
Trick time.
No. Okay.
Yes.
Trick.
Trick time. I don't like that formula because it's, well,
Wide and circle.
it's horrible. There's one more, actually there's two more that are really nice.
So is pre-cal.
If you take this thing and multiply top and bottom by 1 minus cosine of u, all underneath the radical,
Well, the bottom one becomes 1 minus cosine squared u.
and 1 minus cosine squared is,
One minus. One minus.
The one that we
1
did.
minus cosine squared equals
Oh, sine.
sine squared.
Oh,
So this becomes the square root of
what?
1 minus cosine of u all squared over sine squared u. Would you agree with that?
You just just
Yes.
remember all this.
Okay.
And 1 minus.
Hold on.
Oh wait, no.
If you have a square root on a square, what happens?
It
They cancel, and they're both being squared, so they both
Cancel.
cancel. So this ends up being just 1 minus cosine of u over sine of u.
So just basically 1 plus cosine.
So this is
Just 1 plus cosine u equals sine u.
I like this better.
Huh?
Huh?
Just use this formula.
Just give us this one.
Oh, I will. I'll give you all
Whatever
three.
the square root.
It went
All right. The squares here are going to cancel with the square root, so it pops out.
Right, never mind.
By the way, this is also equal to the sine of u over 1 plus cosine of u.
Is it y?
That's an identity we proved earlier when we were in section 1.
So
I proved that this one was equal to this
That
one.
one.
You can also go back and multiply top and bottom here by 1 plus cosine of u.
Yeah.
It works, but you get this one also.
Section 1 was, wait, like,
5-1. It was
oh, I
3
thought you meant,
days
like,
ago.
chapter
3
one.
classes ago. Alright, so that's the cosine half angle, sine half angle. The nice one about tangent half angle is it's irrelevant to sine.
Why?
It doesn't have the plus or minus anymore. You don't have to worry about where the angle is. The cosine and sine will give you the correct positive and or negative that it needs, which is kind of nice.
No, no.
It's not nice.
It is nice.
Math is nice.
Math is nice. This chapter, out of all of them, nobody likes for some reason. I always thought it was kind of cool.
aliens.
I'm an alien. I'm an alien.
They're all men in black.
At all. Like one.
It doesn't
Paul
make
Will
sense.
Smith in here.
No.
Oh, it's really nice though.
There
If you
are
go
three
tangent,
numbers in that whole math equation.
Yes, he is.
okay?
Yes, he
there you
is.
go. Number.
Do it.
Tangent of 15 degrees.
You gotta do that.
You take,
But-
is u the angle?
I have to choose an angle that I know.
30.
So I'm going to change it to 30. So this becomes tangent of 30,
Minus
but there's a
15.
problem.
Divided by 2.
I'm looking for tangent of 15, so I have to divide it by 2. Now I can use my half angle formula, which is 1 minus cosine of
30.
the top number, which is 30, over sine of
30.
30, with the sing-song voice.
Yay.
Yeah, there we go. So this equals 1 minus, what's cosine of 30?
Square root of 3 over 2.
Yeah, it is. isn't
No,
it?
it's not.
Yeah, it is.
Genius.
over sine of 30.
Oh wait, yeah, it is. So it's 1 over 2.
1, 2.
1/2. Simplify. Multiply everybody by
Half.
2.
1, 2, yeah.
When you multiply by 2, it becomes
2 minus.
2 minus the square root of 3.
all over
None.
1. Well, not none, but 1. 2 minus square root of 3.
I
So
said
this
none,
is
not
the
none.
tangent of 15 degrees. Do you like that better?
I got
Yes.
that one right, actually.
Oh, even better.
I said over 1 instead of over none.
I didn't say none.
She said none.
I did not.
I heard none.
How about cosine of 15 degrees?
Okay, done.
Do cosine of 15 degrees.
You said do it? Alright.
Fine. Does it get harder?
If you would have
One.
enunciate.
I'm trying to do it, but you know, none over here.
Wait, what? Did you
Alright,
see what I think you said?
No.
Smith,
No. Yeah.
cosine 15.
You didn't ask me.
Cosine 15 degrees. Did I erase the formula? Yeah.
Yeah, you
But it's
did.
right here. It's in the bottom. This is the bottom piece.
What? So would this be
We'll put this
positive?
in the calculator.
It's definitely positive because cosine is a acute angle positive. Once it's acute, you're fine.
I don't care.
Wait, so what is it? This one?
It should be.
I got 1.19.
Cosine of 30 over 2 is equal to the positive square root of
1
1
plus
plus
cosine
cosine
Smirty
30
over 2.
Smarty?
over 2.
Smarty.
1.19.
Alright?
Do you want us to
No, I want to write this out 1.19.
So it's 1 plus square root.
I'm going to try to write it properly. So this is the square root of 1 plus
Square root of 3 over 2.
square root of 3 over 2
Divided by
over 2. Multiply everything on the inside by
2.
2. This becomes the square root of
2 plus
2
square root of
plus the square root of 3 all over
1.
4.
4?
2
Oh, 4,
times
4,
2
4,
is
4, 4.
You
Shut
have to
up.
multiply by 2, not divide by 2.
silly.
Because I don't, you have a common denominator. So get rid of
No.
the complex fraction.
Make it up for 1/2.
Oh, a half of
What's the square root of 4?
2.
2. I can, that simplifies. So I get the square root of 2 plus the square root of 3 all over 4. Now, we have this answer from a previous one, the,
2.
yeah,
Two.
That's the second time you've been wrong today.
I know,
don't
isn't that
trust you
horrible?
anymore.
That's because I'm thinking of the other part. We got an answer from this before that was the square root of 6 plus the square root of 2 over 4. These two numbers are equal. They have to be, because we did it properly both ways, but they don't look anywhere
The same.
the same. But if you type them both in your calculator, they give you the exact same answer.
How can you do this?
And there's a way of manipulating this one to create this one, and it is not friendly.
Well, we'll leave it like that then.
Yeah, we'll leave it like that. So this is also the cosine of 15 degrees.
Why cannot we put